Hi everyone, welcome back to Chapter 4, Sensation and Perception. For today's videos, we're going to split it up into, I think, 2 videos, maybe just one. We're going to talk about cognition and vision. So pretty much, now that we know how vision works, let's put it together with psychology and figure out how that works together. Now, I believe I've given you guys a link to a YouTube video, which is very fun to watch. If you're just interested in learning some more about this, this video talks about inattentional blindness, which refers to the failure of unattended stimuli to register in the consciousness. In other words, when you see something without really seeing it. So this could be like when you pick up your phone to check the time, and you clicked the button, the home, to see the home screen, and you put the phone down because you saw it, but then you don't remember seeing it, so you have to look a second time. That's inattentional blindness, where your eyes saw it, but your brain didn't register it. And this is something that you can see a lot when thinking about drinking and driving. Because you're drinking, then you're not processing things as fast or as well. So a lot of times people don't register seeing something that could help them prevent an accident. And that's why we don't drink and drive or do drugs and get high, including marijuana. And that's my PSA. So let's get into cognition and vision. The first thing we're going to talk about is bottom-up processing. So bottom-up processing emphasizes the stimulus characteristics that are important when you recognize an object. So pretty much you start with the individual elements that make up an object, then you put them together and then interpret it as a whole. So another way you can think of this is if you've heard the term see the trees before the forest. So bottom-up processing, you see the individual trees. You put all the trees together and you understand that you're looking at a forest. Now, the opposite of this is top-down processing. And this is pretty much like seeing the forest and then breaking it down into its individual components to see the trees. For top-down processing, we interpret sensory information in light of existing knowledge, concepts, and ideas. So contextual factors and their related expectations can affect the speed of object recognition. In other words, if you're used to seeing someone all the time, like your teacher at school all the time, say like your high school teacher, and then all of a sudden you're at the club and you see someone and it's them, you're not going to recognize them as fast because they're in a different context. Also, that just seems very scarring, and I hope that never happens to you. But in top-down processing, then this is especially strong when a stimulus is registered for just a fraction of a second, when the stimuli are incomplete or ambiguous. So, for instance, when looking at the sentence on the bottom, the man ran, the very top is cut down, but we're still able to you look at this and you immediately say, like, the man ran, even though if you were to look at this at individual elements, then this is an H, and over here, this also looks like an H. But when you're looking at the whole thing and top-down processing, you're filling in the gaps to see the whole overall thing rather than the individual components. Whereas if we were doing bottom-up processing, then you wouldn't be able to read this as fast because you'd be like T, and H, E, and then M, H, N. That doesn't make sense. So you've got to kind of step back and look at the whole thing in order to understand this sentence. So this is what this last point is really talking about. The top-down processing is especially strong when stimuli are incomplete or ambiguous because your brain kind of wants to fill in the gaps. So now that we know the two types of processing, we're going to switch into learning about Gestalt Psychology. So Gestalt Psychology is the biggest term, the biggest thing we're going to talk about here in understanding perception. It's especially strong in vision, and it's the main kind of most accepted theory when talking about vision and cognition. So Gestalt Psychology says that humans have basic tendencies to actively organize what they see. For humans, perception, the whole is greater than the sum of its parts. In other words, Gestalt theory is saying that top-down processing is ideal and is usually chosen first by your brain. So an example, if we look at the drawing on the bottom, the first thing you do when you look at this is, for me, I see a face, because I see an oval and two eyes. And that's top-down processing. I'm using, I see all of it, but then I can break down the individual things into an oval and two lines. So here, the Gestalt theory is saying that we see the overall quality transcends the individual elements. So Gestalt theory can be broken down into a few different subsections, and one of those, you don't need to know all of them, but one of them is figure-ground relationships. So this is organizing a scene to a central figure or a focus and a background. So humans, us, we're very good at focusing on a figure. So this is where some optical illusions can start to come in, where we tend to focus on the thing in the middle, the figure, rather than the background. So the figure here, the thing in the middle, would be this lovely vase in the pinkish white ombre thing. However, some of you might first see two faces in the black on the side. So this is where you have to decide what's the figure and what's the background. So if the figure is the vase, then the black stuff's the background. Now the opposite is, well, what if the figure is the two faces and this ombre color is like a sunset in the background? And so that's kind of what figure-ground relationships are. Now, if we look at other types of figures, like if we just go back to this figure here, then, this would clearly be the figure, and then this is the background. Or if you're talking about like the text on the slide, that's clear. But we can have these optical illusions, like this one here with the faces and the vase, where it's hard to decide what is the figure and what is the background. So here's some more examples of ambiguous figure-ground relationships. So we've got this one here. Is this a woman walking in a town? Or is this the picture of a nose and mouth of a man? So you can see kind of here the face, here's some eyes, and then if this is the nose and this is the mouth. And then this image in the middle is a lot more popular. You might have seen this before. And do you see an old woman or do you see a young lady? So for the young lady, then this is her face here, this is her hair, and then this is like a hat or something, I don't know. But if you change your view, then with an old lady, then we have the nose here. This is the mouth, so her face is all of this. Okay? And then again the hair. So her eyes, the old lady's eyes are right here and right here. Whereas with the young lady, she's looking to the side. So this is her nose, this little thing here. This is her chin, and then her ears are over here. And then this is her neck. So you can kind of see how, based on what you focus on, you'll see different things. And then we've got another example over here of, is this a lady looking in a mirror, or is it a skull? So we can talk about Gestalt reversals. And so Gestalt reversals are important in kind of being able to see the different images within an optical illusion type thing. So we've got bottom up, so this is the neurons in the visual cortex become adapted to one figure, so you are more likely to see the alternative. And then top down is people actively try to solve the visual paradox by switching between the two reasonable situations. So with top down, then you're able to switch very easily from one version to the other. So I was using a lot of top down in the previous slide, pointing out the differences. In bottom up, then pretty much your eyes, you can only see one of the versions until you're staring at it for so long that your visual cortex becomes adapted to that figure. So when you look at it again, you're more likely to see the alternative. So basically by staring at it for a very long time and then kind of like closing your eyes for a couple seconds and looking again, then you're more likely to see the second option. We also have some illusory contours, which is that you can see the boundaries that don't exist. So this is another type of Gestalt psychology, pretty much saying that our brain fills in the gaps. Examples for both of these would be that you can see the square in the middle here. And that our brain, what it does is it kind of creates boundaries and it kind of fills in the gaps here to create that perfect square, where in reality, it's really just four kind of Pac-Man coming in together, and there's just a gap in the middle that happens to be a square. It's not that there's, four blue circles with a yellow square on top. That's kind of what our brain makes us see, when really it's four of these pie shapes facing each other. So the laws, the Gestalt laws, can be split into four different types of organization as well, because remember, Gestalt law says that we love to organize things. And so there's four main laws I want you to know. There's the law of similarity, the law of proximity, law of closure, and law of continuity. So let's kind of talk about those individually. So let's start with the law of similarity. So pretty much what that's saying is that what we're naturally going to do is we're going to group things that look the same. So in this image here, then we've got a bunch of circles, and there's two different sizes of them. And what our brain's going to do is we're going to group the dots that are the same size together, rather than grouping a bunch of dots that aren't the same size. So, for instance, what I see is a big triangle of little dots with one in the middle as like a group, and then we've got three big dots on the outside. And what my brain did, was it grouped all the dots that are the same size to form an image. If we didn't do this, then maybe we'd see like group these together or group this together. Like we could really group things together differently if we're not using the law of similarity. But that's just confusing, and let's not do that. The second law of organization is the law of proximity. And this one's pretty similar. Pretty much things that are closer together get grouped together. So for example here, if we were using the law of similarity, we'd group these long lines together and the short lines together. But that doesn't really make sense in this example because they're still far away from each other. So here then we're using law of proximity, that there's 3 sets of 2 of a short and a long line. Whereas law of similarity would say you have 2 sets of 3, where there's 3 long and 3 short. So that's the difference between proximity and similarity. Now the next one is law of closure. And law of closure is pretty much saying that we are going to close the edges of an open figure. So here, it's kind of a C shape with all those dashes, but what our brain's going to do is it's going to close this and create a full circle. And if we look back at the last slide, that's pretty much what our brain was doing here. Was we were kind of closing the edges here to create that square. Now the last one is law of continuity, and what that's saying is that pretty much if I were to draw a straight line, let's draw lines here connecting all the dots. You can kind of see how I'm using the law of continuity, but the law of continuity is saying that instead of seeing 4 separate lines, so there'd be like that's A, and then we've got like D and B and C, so we could have, are there 4 lines, or is there a line that goes like that, and then another one that goes like that? That doesn't really make sense. So law of continuity is saying that that's a line, and then the second line goes like that. Okay, so that's what law of continuity means, is that this line isn't going to suddenly diverge. It's going to go in the straightest line possible. It's going to continue in a smooth line. So that's what law of continuity says. It's saying that this is not right, that's not right, but this one is, where we have one line that's from A to B and the second line that's from C to D. Okay? Now there are some other fun optical illusions that we're going to talk about real quick in the next video.